Hi guys, this is O-level chemistry, paper 12, June 2020, question 21. Which aqueous reagent liberates ammonia from ammonium nitrate on warming? Okay, calcium nitrate. Now, calcium nitrate is a neutral salt, so it will not act as a base to liberate ammonium ions from ammonium nitrate. Next is potassium hydroxide. Potassium hydroxide is a base. It would react with ammonium nitrate, liberating ammonia gas because ammonium nitrate is an acidic salt. So a base would react with an acidic salt to liberate ammonia gas. So this is the answer. Sodium chloride. Sodium chloride is again a neutral salt, and sulfuric acid is an acid. An acid will not liberate ammonia from an acid salt. In fact, if ammonia is present, the acid itself would react with it, forming ammonium sulfate. So there is no chance ammonia gas can be given off. And as for potassium hydroxide is concerned, the reaction would be KOH plus NH4 NO3, giving us ammonia gas, potassium nitrate, and then we have H2O forming. So this is the reaction that is taking place. We have production of ammonia gas here, making option B the correct option for this question. Question 22. Two fertilizers are made by mixing chemical compounds. Fertilizer X contains 500 grams of ammonium nitrate and 500 grams of ammonium sulfate per kilogram. Okay. And fertilizer Y contains 700 grams of ammonium nitrate and 300 grams of calcium sulfate per kilogram. Which fertilizer contains a higher percentage of nitrogen by mass and which contains a higher percentage of sulfur by mass? Okay, MR of ammonium nitrate, ammonium sulfate, and calcium sulfate have been given to us. Now we need to calculate the mass of nitrogen present and mass of sulfur present. So for nitrogen, we have in ammonium, what is this? Ammonium nitrate. Okay, ammonium nitrate has a mass of 80, MR of 80. So in fertilizer X, we've got 500 grams of ammonium nitrate. That means we've got two atoms of nitrogen here. And in the rest of the 500 grams, we've got another two atoms of nitrogen. So in total, we've got 4 moles of nitrogen in 1 kg of fertilizer X. And in fertilizer Y, out of the 700, we only have two atoms of nitrogen, so 2 moles, and there is none present in calcium sulfate. So this makes fertilizer X have a greater percentage of nitrogen because out of the 1 kg, there are 4 moles of nitrogen present, whereas in the case of the second one, only 2 moles are present. So X is the correct answer for the first column. So options C and D have been eliminated. Now let's look at the fertilizer with the higher percentage of sulfur. So in the case of ammonium sulfate, we've got one sulfur atom present, so 1 mole of sulfur, and the mass of sulfur would be 32 out of the total mass would be the mass of ammonium sulfate, which is 132, and the mass of ammonium nitrate, which is 80. So 32 out of this sum is the percentage of sulfur present or the ratio of sulfur present, moles of sulfur. And in this is X, right? In Y, we have got 32 as far as calcium sulfate is concerned, upon we have 136 as the MR of calcium sulfate and 80 as the MR of ammonium nitrate. So we are ending up with these two ratios. Okay, but there is another issue here. In fertilizer X, we've got equal quantities of ammonium nitrate and ammonium sulfate. But in fertilizer Y, we've got 700 grams of ammonium nitrate and only 300 grams of calcium sulfate. So there is lesser calcium sulfate. So what we will do here is now for X, we will calculate 32 grams are present in, uh, this is ammonium sulfate, right? So ammonium sulfate is 132. In 132 grams of ammonium sulfate. And ammonium sulfate is 500 grams. So how much sulfur would be present in 500 grams? So this will give us a value when we divide 500 by 132 and multiply this by 32. This gives us a value of 121.2 grams. So we have 121.2 grams present in fertilizer X, sulfur in fertilizer X. And for the other one, we have 32 grams in 136, which is the MR of calcium sulfate. So how much would be present in 300 grams? So this will become 300 divided by 136 and multiplied by 32. This gives us a value of 70.5 grams. So we have 70.5 grams of sulfur present in the 300 grams of calcium sulfate and or other kilogram. And we have 121.2 grams present in 500 grams of ammonium sulfate. So this shows that X has more sulfur present in it compared to Y, which makes X the one having a higher percentage of nitrogen and the higher percentage of sulfur as well. So between options B and A, B has Y quoted as the one with the higher percentage of X, which is wrong, and A has X quoted as the one with the higher percentage of X, which is correct, making A the correct option for this question. Question 23. Which processes occur in the manufacture of sulfuric acid? Burning sulfur in air? Yes, that is how we get sulfur dioxide. Dissolving sulfur dioxide in sulfuric acid? No, this process does not happen. Dissolving sulfur dioxide in water? This also does not happen. And reacting sulfur dioxide with air to convert it into sulfur trioxide? Yes, this happens. So, out of the four given processes, process 1 and 4 are correct, making option C the correct option for this question. Question 24. A lump of element X can be cut by a knife. Okay. During its reaction with water, X floats and melts. Okay, so both of these properties point towards a metal from group 1. Both properties belong to a metal from group 1. What is X? Calcium. Calcium is in group 2. Copper is a transition element. Magnesium is a group 2 element. Potassium is a group 1 element. So, option D is the correct option for this question. Question 25. Chlorine is passed into separate samples of aqueous potassium iodide and aqueous potassium bromide. In which solution is there a color change? So in potassium iodide, iodide ions will convert into iodine, forming a brown solution. And in potassium bromide, Br negative ions will convert into Br2, producing an orange solution. So there is a color change in both. So A has a color change taking place in both the solutions, making A the correct option for this question. Question 26. Which diagram shows the structure of an alloy? Okay, in A, we have got two representations, a small circle and a large circle. These represents atoms of different substances or different elements. So this is how an alloy can appear. Yes. B is the structure of graphite. This is known just by looking at it. So this is not an alloy. C is an ionic lattice. An alloy is made up of a metal and a metal or a metal and a non-metal. So not an ionic compound. And D are ions together. So this is what happens in a metal, arrangement in a metal. So the only one that represents the structure of alloy is A, making option A the correct option for this question. Question 27. Which element can only be extracted from its ore using electrolysis? Okay, metals that are more reactive than hydrogen, or in fact iron. So we have silver and copper are less reactive than hydrogen. Lead is more reactive than hydrogen but less reactive than iron. More reactive than hydrogen, less reactive than iron. Yes. So none of these. Calcium is a highly reactive metal. It can only be extracted using electrolysis. So option A is the correct option for this question. Question 28. Which equation shows a thermal decomposition that occurs in the blast furnace? A thermal decomposition. A represents oxidation or combustion. B represents reduction. C represents calcium carbonate going to calcium oxide and CO2. This is decomposition. And D represents calcium oxide plus SiO2. This is a base reacting with an acid. So this is an acid-base reaction, a neutralization reaction. So this is also wrong, which makes option C the correct option for this question. Question 29. Which diagram correctly shows the condition necessary for the rusting of iron and also the metal that can be used to prevent rusting by sacrificial protection? Okay. Option A, the condition is oxygen, which is not the only condition. We need water as well. So oxygen only is in A, oxygen only is in B. A and B have been eliminated. C and D both contain oxygen and water, which is required for rusting because moisture from the air is responsible for conversion of iron to iron 3 oxide. And the metal to be used should be more reactive than iron. In C, we have copper. Copper is less reactive than iron. This cannot sacrificially protect iron. And in D, we have magnesium. Magnesium is more reactive than iron. So it will react with water and oxygen more readily than iron, making it the appropriate metal for sacrificial protection. This makes option D the correct option for this question. Question 30. Aluminum is produced by the electrolysis of pure aluminum oxide. One of the electrodes in the process has to be replaced often. Yes, the anode, because it burns away in oxygen. Which statement is correct? The product at the anode reacts with the anode. Yes. Oxygen produced reacts with the carbon brushes of the anode at the high temperature that is being used in the process, and it burns away to form CO2, so it has to be constantly replaced. B. The product at the anode reacts with cathode. No, they are separate. The product at the cathode reacts with the anode. No. The product at the cathode is aluminum metal. The product at the cathode reacts with the cathode. Aluminum metal does not react with carbon. So, carbon burns away in oxygen producing CO2. This is the reaction that takes place at the anode, in which the anode itself gets used up. So, option A is the correct option for this question.